So please join me in giving Bryan a very warm Modesto welcome.
I'm here tonight to talk to you about the Maya apocalypse, or Doomsday 2012, which I'm sure most of you have heard of. And if you haven't, I'm not sure where you've been. And then I'm basically the structure of the talk will be to talk a little bit about the Maya and the calendar that's led to this idea of some prediction of doomsday in the year 2012. And then I'll also talk specifically about some of the geophysical and astrophysical doomsday scenarios that have been put forward as possible ways that the Earth could bite it. And we'll look at those scientifically and find out what's the evidence for those. As was mentioned earlier, as I'm going through the talk, if you have questions, it's a very large crowd, so I won't be able to engage everybody right away, but I would like to kind of grab the, get the pulse of the crowd as we're moving through. We'll have the formal question and answer session as normal at the end of the talk as well. But if you have questions, go ahead and pop your hand up at any point, and I'll make a point to address those. So let me get started. So I'm going to start out by telling you a little bit about the Maya, because they're the ones where this all begins. So the Maya are actually a name that was given to an ethnicity of people after the fact, right? So the Maya never actually called themselves the Maya. It was a name that was given to them by archaeologists much later in time. But the term describes this group of people who lived in this region of Mesoamerica that's pictured here. So running from the Yucatan of Mexico through the countries of Guatemala, Belize, El Salvador, and a little bit of Honduras. The Maya have been in this area of the world for thousands of years. Their history has been kind of divided up by archaeologists kind of based on progression of civilization. So there was what's called a pre-classic period, which is when they had early civilizations, early city building, although some of the largest cities that the Maya built were built in that period, roughly in the years, the few centuries before 1 AD. And then they reached the height of civilization about 2,000 years ago. Throughout the region, there were hundreds of cities that had hundreds of thousands of people living in them. At the time, some of the Maya cities were the most populated cities anywhere in the world. And so compared to Europe at the time, so Rome was one of the most populous cities at that time, some of the Maya cities were much larger actually in population. Around 900 AD, however, there was a steep decline in populations in the cities. There was this mass exodus from the cities and a collapse of the overall political structure. One of the most common misconceptions about the Maya is that they don't exist anymore, that they somehow mysteriously disappeared. And so that's the first misconception that I want to address and point out, is that the Maya did not disappear. Their political structure fell apart. But the Maya people remained. It's kind of the same as saying, the Roman Empire fell apart, but the Romans still exist, right? In fact, the city of Rome still exists. So the Maya people, today there are over 6 million of them living in Mesoamerica and throughout the world. Some of them are archaeologists working at the sites. And some are actually these folks here live in the United States and are working to preserve and promote Maya culture among immigrant populations in the United States. So they're a very vibrant and living culture. So that's the first thing to know about the Maya, is that they're still here with us. They didn't go anywhere. So Maya calendars. That's where the story begins. So I'm going to show you this image, which you've probably never seen before. Actually, how many of you have ever seen this image before? Okay, 2. There are many Maya calendars. That's why there's that S there. You'll often hear about the Maya calendar predicts the end of the world in 2012. So that's the phrase you often hear. And there's actually what you'll hear is the Mayan calendar predicts the end of the world in 2012. So there's almost nothing that's good in that sentence. Archaeologists they only use the word Mayan to refer to the languages of the Maya. The people are Maya, and anything related to them are Maya. So the only thing that's Mayan is the language. So it's a Maya calendar, and there are many of them. The Maya had several different calendars for several different purposes, and there are actually 2 of them that are still in use in some pockets of Maya culture today. And one of them is a 260-day calendar, meaning that there's a cycle of 260 days that just repeats over and over again. It's actually made up of 13 months of 20 days. And then they have a 365-day calendar, which is a solar calendar. And that one, again, just repeats every 365 days. It's made up of 18 months of 20 days, plus 1 month of 5 days. Those calendars go together. They're always kind of, you always see them used together, and dates are written with both those calendar dates appearing with them. And because there's 260 days and then 365 days, you can kind of think of them as like 2 different wheels rolling at the same rate, but because one's bigger than the other, they only match up at the same spot. So in other words, the same pair of dates in the calendar only occur once every 52 years. So that's what the Maya refer to as a calendar round. And so they often, and I should say actually that this set of calendars is not unique to the Maya, and it actually predates the Maya. We think that the ancient Olmec civilization, which is sometimes referred to as the mother civilization of Mesoamerica, may have been the inventors of this pair of calendars. And then it's used throughout Mesoamerica. The Aztecs use it. They have different names for them, but they still have that same functionality of 260, 365 days. One thing I'll mention about the 260-day cycle is that there are lots of different ideas as to where those 260 days come from. Some are astronomical. An example is the cycle of Venus as either the morning star or the evening star is roughly 260 days. Another astronomical possibility is that it could be related to the moon phases, because 260 days is almost 9 months, lunar months. At tropical latitudes, and this is a little harder to get your mind around, so I'll just say it quickly and you can gel on it later. But at the latitudes, especially in the early period, let me go back to this map. At this latitude, right around here, where some of the oldest cities in classic Maya history developed, there's a relationship between the time between passages of the sun going straight overhead and the solstices. And it turns out that the amount of time between solar zenith passage to the winter solstice back to solar zenith passage is 105 days. And then it's 260 days back to the other. It also happens then to relate to the cycle of corn and the cycle of humans. The cycle of corn is about this 105 days, and the cycle of a human is about 260 days, 9 months, the gestational period of a human. And in fact, it's a common tradition even today in some indigenous tribes to name children based on their day that they're born in the 260-day cycle. The idea being, if you're born this day, then because it's a 260-day cycle, that's probably also the day in the calendar that you were conceived. So that's often a common naming convention. Now, this is an image that you see all the time when people are talking about the Maya calendar. It is not Mayan and it's not a calendar. All right, so if you see this image in relation to someone talking about the Maya calendar, that's your first clue that they may not know what they're talking about. This is called Piedra del Sol, which means the sunstone, and it's Aztec. And the Aztec were a people who were hundreds of miles away and hundreds of years later in time than the Maya. Some of their culture was influenced by Maya thought, but they are a distinct ethnic group. The analogy that I'll sometimes make for people to help them understand is think about, say, the difference between the ancient Greeks and the Romans. You know, the Romans were influenced by the Greeks, but they're a completely different culture. This is kind of the same thing. The Maya were a different culture than the Aztec, and this stone, while it's beautiful and iconic, doesn't have anything to do with the Maya. Nor, by the way, is it a calendar. It has a few calendar glyphs in it, here, 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 and here, but it's not a calendar in the sense that you could put a stone on it and mark, okay, today is this day. It's a piece of artwork. It's actually probably was used as a religious altar. It evokes ideas of Aztec cosmology, but it wasn't used to keep time. Although I'll say, flying in the face of that, when I was growing up, my dad had a clock that the face of the clock was this and had the hands running around it. Okay, so the actual calendar that gets everybody in an uproar actually doesn't have a name in Mayan. And the reason for this is because it fell basically in disuse at the end of that classic period. When the political structure collapsed, the use of this calendar went with it, because it was basically the calendar of the kings. It was the calendar of the priesthood that was supporting the kingships. They used it to record history and to mark dates over long periods of time. And the period of its use basically follows exactly this classical period of the Maya civilization. So, since it fell into disuse at the end of the classic period, by the time the Spanish had arrived, some 600 years later, nobody even knew about this calendar, and no one had a name for it. So, in modern archaeology, it's simply been given the name the long count, because it's a long count calendar. It counts days over a long period of time. For the astronomers in the crowd, it's probably very similar to what we call the Julian day calendar. But it's also, I'll describe how it's not too dissimilar from the Gregorian calendar that we're familiar with as well. I'll briefly describe the fact that it has several different levels of cycles, but they're not really different from the ones that we're familiar with. The first basic cycle is a day. We're all familiar with a day. And then there are groups of days, which we can think of as months, 20 days, that are called winals. The reason for the 20, by the way, is because that's the basic unit of the Maya counting system. We're familiar with a decimal counting system where the base unit is 10, and the Maya went with 20. And the usual supposition for the reason why they went with 20 is because humans have 20 overall digits. We have 10 fingers and 10 toes. You know, part of the reason we think that we use the decimal system is because of the 10 fingers, and I guess, you know, we forgot about our toes. So there are groups of 20 days called a winal. And then there's grouping of those winals, so the months. There are 18 months inside of what is called a tun. And why 18 instead of 20? Because 20 would have been the normal thing if you're just going to keep counting up. The reason is that 18 winals is equal to 360 days. So it's very close then to the solar year. So the idea here probably was to keep the tuns close to the length of time of the solar year. The Maya knew the length of the solar year with very high accuracy. In fact, they knew it within about a few seconds of its modern known value. It's pretty incredible. And I should say, and people often marvel at that, wow, I can't believe that. And it is a pretty amazing accuracy, but what it really is a testament to is that they were such careful observers and careful record keepers, because in order to achieve that level of accuracy, you need records that span centuries. And so in order to have those century-long records and have been so meticulous in counting days and observing the sun is a real testament to how careful observers they were. All right, then there are groupings of the tunes. Again, we go back into the 20s, so there are 20 tunes that make a katun. And then there are 20 katuns inside of a baktun. So a baktun is a total of 144,000 days, or 396 years. So that's the way the calendar works. It just counts days. And here's an example of it. If you're interested in trying to read these, The Maya numbering system is pretty simple. There are only 3 symbols. There's a dot, which stands for 1. There's a bar, which stands for 5. And then there are shells, or some other kind of shell-like glyph, which stands for 0. So 9 is written with 4 dots in a bar. 16, 3 dots in a dot. And then here's a 0. So this is the way we often see long count dates written in Maya texts. It's vertical instead of horizontal as we're used to. And then they also always write their long count dates with those other 2 cycles, the 260-day cycle, which the Maya call a Tzolk'in, and the 365-day cycle, which the Maya call the Hab. So we always see those long count dates with the Tzolk'in and Hab dates associated with them as well. So they're using a lot of different calendars at the same time often. But modern scholars just kind of use this shorthand where they just write the numbers in the horizontal way that we're used to. Now, the long count date, if you're going to count days, you need to pick a starting point. And the starting point that the Maya decided to pick was creation. At least their mythological idea of when creation started. And the interesting thing about the way they wrote the creation date is they wrote it with all zeros, except for in the Tzolk'in and in the Hab. They weren't zeros, they were specific dates in those cycles. And they wrote the Baktun, interestingly enough, as 13 rather than 0. And that's a little interesting. I mean, in our mindset, if we were starting in year 0, we would have written 0. Although the Gregorian calendar doesn't start with 0, it starts with 1. So we might think 0 or 1, but why 13? 13 turns out to be a number that the Maya were very interested in numbers. And one of the reasons they were probably such meticulous astronomers is because there was such wonderful mathematics to be done in astronomy. And that really played into their sensibilities and their sense of the cosmos, because they could kind of see this cosmic order unfolding in the mathematics. And 13 was a number that they especially had an affinity for. So, but beyond that, what does that 13 mean? And I'll tell you kind of 2 interpretations, and I won't say which one I think is preferred, because I don't know that I really know if there is any preferred. But one interpretation would be to think that, like the other calendars, the Maya may have conceived of the long count as also being cyclical, that there was some basic large cycle, and then it would reset after that cycle comes to completion. And so you might think of the long count kind of like we have a clock. 12 is 0, 0 is 12 on the clock. You never actually write 0, you just write 12 o'clock. And so it might be the same with the Maya long count, that it resets always at 13. Another interpretation would be that what they're saying here, because one of the things that I didn't tell you about is in their mythology, they had other periods of creation, other ages of the world that were before us. So they had this idea that, for example, the gods, when they first tried to make humans, they made them out of clay. But the clay people weren't all that great. In fact, they washed away in the rain. So they weren't so good. So the gods started over, and they tried, and they made people out of wood. The wooden people were a little better than the clay people, but they also weren't very satisfying to the gods. They were kind of stiff. And so the gods decided to wipe them away and start over. And it's that next age, which is our age, the current age of the world, where the gods made humans out of corn. And they were much more pleased with their corn humans. And one of the things that's important there also to notice is that each age gets better than the last one. The gods kind of learn from their mistakes, and each age gets a little better. And so one interpretation might be that what this indicates is that is the length of time of the previous creation. The creation of the wooden people lasted 13 Baktun, and then came to an end and started over again with our modern age. So those are 2 possible interpretations for what that might mean by writing that 13 Baktun. So this is a little bit more on what I just actually said, but I think one of the points that I just wanted to make here was this idea of setting the calendar dates to a specific important idea in your overall worldview is not unfamiliar to us at all. In fact, the Gregorian calendar was set in a similar way. The original idea behind the Gregorian calendar was that day 1 was supposed to be the birth of Christ. Now we know that the first monks who tried to figure out when the birth of Christ was in the Julian calendar and adjust it got it wrong by probably several decades, but that was their intention. And it's still kind of the popular idea of the Gregorian calendar is that the first day of the Gregorian calendar is the day of Christ's birth. So it's not unusual for us to to encounter calendars that have start dates like this. But there's a trick now, or there's a bit of a problem. Because the long count wasn't used by the time that the Spanish had made contact with the Americas, there was no way to directly correlate the calendar of the Europeans with the calendars of the ancient Maya because they weren't contemporary. So you have to do a lot of detective work to actually then try to figure out what do these dates actually correspond to in European calendars. And the important piece of information actually turns out to be, oops, let me go back a bit, is the fact that the Maya always wrote the Solkin and Hab dates with their long count dates. And at the time of the Spanish conquest, the contemporary Maya people of those times and the Aztec people were all using some version of the Solkin and the Hab and writing dates in those. And so what modern scholars have tried to do is to run back those 52-year cycles and see if they can match them up with some of the historical inscriptions they see written on buildings and in the archaeological record. So when they do that, they've also tried I should mention that the Maya only left, not that the Maya only left, but there are only 4 books of the ancient Maya that have survived to modern day. Most of them were all burned by the Spanish when their attempt to suppress Maya culture. So we have very little knowledge about the Maya except for what's written on buildings in modern archaeological digs. And those 4 books just happen to have quite a bit of astronomical information in them. So one of the other games that people have tried to play is to see if they can match up some of the astronomical observations and dates that are in those 4 remaining books with known astronomical alignments, say some eclipses, for example, because there's an eclipse table in one of the books. So after they do all that work, has led to most scholars agreeing on one correlation, which gives the start date of the calendar in the, compared to our Gregorian calendar, it would be August 11th of 3114 BC. Now, there's another group of scholars who are just slightly smaller than that other group who think that it's 2 days off. It's 2 days later than that. The start date was August 13th of 3114. So if we write today's date then in this system, we'd be at 12, 19, 19, 13, 19, and then, 1, and then the Solkin and Hab dates would be 9 Imish, 4 to N. And we, of course, write our dates like this. 2012, 9, this was yesterday's date. I gave this talk yesterday, too. So that means there are 98 days until we reach 130000 again, which was the creation date. All right? So that actually is kind of the thing that seems like it's really, the big thing that's coming to a head. What does it mean that we're reaching 130000 again? It also happens to be 4 Ahau, which was the Solkin date of creation. However, it's 3 Kankin, which was not the Hab date at creation. I don't know if that matters to people, but it's not exactly the same date as creation. But this is the big question. What does it mean that we've reached that date again? Some people think it means destruction. But I say it means nothing. And I'll give you a couple of reasons. One is that we have just barely scratched the surface of Maya inscriptions and Maya all of the Maya sites. There are probably, it's estimated, thousands of archaeological sites throughout Mesoamerica that are still uncovered. And the ones that we have begun to excavate, we've only scratched the surface of them. And one of the things, for example, that we've discovered is that the Maya lived at sites for thousands of years and built on top of and on top of and on top of. Many of you are familiar with the El Castillo at Chichen Itza, that great pyramid. How many of you knew that there's another pyramid inside of it? Yeah, a much older pyramid that basically the later generations just built on top of. And as you start going deeper and deeper, you start finding more and more fascinating history. But in all of the things we found so far, all of the long count dates that refer to something that's not contemporary, meaning most of the dates that are written are referring to something that's happening right now. This is the date that we built this building. This is the date that our king was coronated. This was the date that our king died. This was the date of this great celebration. The only time that they talk about past or future events, they're usually referring to creation. That seems to have been a much more interesting date for them, was creation date. And there are only, until a month ago, there was only one example of someone actually referring to the future 13th Baktun. And then actually a month ago, it was released that a research group had found a second inscription that refers to the coming 13th Baktun. Now, the thing that's kind of funny about this first one, this was the one that was first discovered, is that it refers to the date, and then it starts to talk about it will happen, and then the glyphs are broken. One of my colleagues, his name is Mark Van Stone, calls this the Murphy's Law of epigraphy. And then just recently there was it was actually an inscription on a set of steps that referred to this future date again. What seems to be happening, especially in this one, is that they're still talking about current events, but they're trying to place those current events in their overall cosmic place. So they'll talk about so many years from now it will be this period ending, and people will still be interested in what we are talking about today. This inscription seems to speak about a ceremony where a priest gets dressed up as a god who is present at creation. But what that priest will then do, of course, we don't know because it's broken. And probably the most important thing, so a couple of things. So there's no written evidence anywhere that the Maya thought that this coming 13th Baktun meant end of the world, destruction, or anything like that. There is evidence, if you study their mythology, that there's no reason that even if they thought that the previous age only lasted 13 Baktun, that this age should last 13 Baktun, because they believed each age got better and lasted longer. So we should be safe for a while, because we're better than the wood people. But I think most importantly is that there are examples of them talking about dates further in the future. One of the great sites that's been uncovered is in the Mexican state of Chiapas. It's called Palenque, and there's one of the longest inscriptions known, talks about their great king Pakal. And they talk about a date that corresponds in our calendar to, I think, 4472 AD. And basically what they're doing is they're saying, our king is so amazing that this far in the future, people are still going to be remembering and talking about him and his greatness. So clearly, the people at Palenque believed that their culture would continue on past the 13th Baktun. So it really isn't correct to say that the Maya predicted the end of the world. They did no such thing as far as we can tell. Nor did they necessarily even have a concept of end of the world. So a lot of scholars actually think that this resetting idea is maybe not correct, because there are some inscriptions that actually show higher orders of groupings. So there are groupings of Baktuns called Piktuns, which are 20 Baktuns. So if some think that really this count should just keep going up. We should just keep going. The next day in the calendar will begin with 1 there, and we'll keep going all the way until we hit the 14th Baktun and the 15th Baktun, so forth and so on. However, there have been many misinterpretations of this date, or some early interpretations of just what that it means that we're coming back to creation. There are other Mesoamerican cultures that have this idea of the world coming to a disastrous close at the end of an age. The Aztec, in fact, do believe that, or I should say did believe that the world came to that kind of conclusion. But the Maya didn't. But discussions about those things kind of filtered out and got legs of their own, if you will. And now it kind of doesn't matter, right? It doesn't matter what the Maya thought, because people have heard that the world is coming to an end in 2012, and oh my gosh, there's all these different ways it could happen. What's going to really happen? So that's what I'm going to talk about. That's what I'm going to talk about coming up. Actually, let me just kind of close with talking a little bit about the astronomical connection. Since I'm an astronomer, I like to talk about the astronomy. And one of the things that's kind of fun is that the end of the Baktun happens on December 21st, or the 23rd, we're not sure which. The 21st is the winter solstice in the northern hemisphere. Winter solstice is the shortest day of the year. That's when the sun reaches its lowest point in the sky, has its shortest path, and it's the longest night of the year. So that's interesting. Is that intentional? Did the Maya mean for it to come to its conclusion then? Hard to say. It's not like the calendar came with an instruction book. Well, what's also interesting is that the start date has several astronomical points of interest that all kind of come together. One is that at those ancient cities that I mentioned at 15 degrees latitude, Copan and Izapa, the start date, August 13, is a solar zenith passage, and the solar zenith passage was very important to the Maya. It also was a full moon, and on that same day at sunset, the Milky Way is splitting the sky. And the Milky Way to the Maya represented the roadway that their ancestors walked to the underworld. And also the constellation Orion, which the Maya saw, the famous belt is actually up here, and the Maya saw this as a big turtle with 3 stones on its back, these stones representing the hearthstones of creation. Every Maya home begins its construction in kind of honoring the way the gods built the earth. They build their homes the same way. They start with these 3 hearthstones, which are the central piece of the home. This is where you cook your food. And so the idea of the 3 stones of creation on the turtle's back are there. This constellation happens to be at sunset very near what's called the nadir, which is the point directly beneath us. So on the day that the sun goes directly overhead, Orion goes directly beneath us. It's a full moon, and at sunset the Milky Way is directly splitting the sky. So there's all these kinds of things there that, are they intentional? Hard to say. Again, didn't come with an instruction book, but we know from other examples that these are all things that the Maya would have, if they were trying to find an astronomical importance for their start date, this would have been a good day. Okay, so let me pause there to just see if there are any questions before I move on to Doomsday. Yes? Use of the number 0 and what's known about when that happened. And most of the archaeological evidence may point to the Maya, not the Maya being the origination of that number system, but in fact the ancient Olmec. So it probably was in the first millennium BC that this number system came about. And sometimes people talk about it, saying that the Maya discovered 0. And I wouldn't so much call it discovery. It's kind of like inventing. Math is kind of a tool, and you invent it to work the way you need it to. And the Maya were one of the cultures that came up with the idea of 0 to help them do their mathematics. And they did that independent of other cultures. The Arabs also independently developed the concept of 0. The Romans didn't, actually. And it turns out that because they had that positional system that they used, it was actually easier in Mayan mathematics to do very large calculations with big numbers than it was for Greeks or for Romans to do those kinds of calculations with their number system. The question was about the concept of linear history versus cyclical history, and whether or not what the Maya believed. And the Maya were very much in the mindset of cyclical. That's why they focus a lot on the 260-day and the 365-day cycles. The long count was probably invented out of sheer need because they began to have a history that was spanning more than several lifetimes. And they needed to be able to mark those things in order to keep their observations over longer periods of time than a human life cycle. That 52-year cycle of those two calendars was kind of roughly the lifespan of a human at that time. So the Maya definitely did have this concept of cyclical history, things repeating, and even possibly similar events repeating on similar days. So yeah, let me take one more question before moving on. Yeah. Well, most of the names that we have for names of the days come from modern Maya people. Yeah, so the question was, if we don't know what the Maya even called themselves, and they probably called themselves more related to the cities they lived in, because the cities were kind of their own nation states. But the question was, how do we know what they named their days? And my answer then being that we know from basically what the modern Maya people called them. And there are actually in existence now 30 different Mayan languages. So it's kind of similar to, there may have been some root Mayan language that's maybe similar to like Latin, and that there are all these now offshoot languages that are similar maybe to Spanish and Italian and French that are the offshoots of that mother language. All right, so one of the first things that starts to crop up when you hear about the 2012, and especially the end date, is this mysterious galactic alignment. It's said that on this day, the sun will be in the center of the galaxy, and that means something. Well, and sometimes they throw in this number. It's 25,772 year cycle. This is the completion of that cycle, and the Maya knew about it, and they meant for something big to happen on this date. So it is true that the sun will be located near the center of the galaxy, but not in the center of the galaxy, on that date, December 21st. But that happens every year. And has happened every year since the Earth formed 4.5 billion years ago. So it is not a special alignment. It happens every single year. In fact, and this concept of the center of the galaxy, we've only located the center of the galaxy in the last 50 years with radio astronomy. If you're a naked eye observer, the Milky Way looks pretty much the same brightness all across it from every single vantage point. And it's very difficult to discern any kind of center of the galaxy. And so because of that, really, the Maya, if they were watching the sun and noting its location in the sky, they would have noticed that it happens twice a year that the sun lands in the Milky Way. 6 months apart, you're going to see the sun here, and then 6 months later, when we're on the other side of the sun, we're going to see it against that part of the Milky Way. Remember that the Milky Way is a disk, kind of like a CD. We're in the disk, so when we look into the sky, we see it as this band that runs across the sky, and it surrounds us because we're in the disk. This cycle of 26,000 year cycle is related to what's called precession. The Earth is a spinning top, and as it's spinning, if you ever spin a top, you'll see that the top begins to wobble very shortly after it's going like this. And the Earth does the same thing, it wobbles. And the cycle of that wobble is roughly 26,000 years. What that does is it changes the date in a solar calendar of alignments of the sun with the stars. Right? So the sun will still always land in that same spot in the Milky Way, which is pictured here. So this is the Milky Way, there's the sun, there's where we know the galactic center to be. It's about 6 degrees away, by the way, which is over 12 full moons distance. Sorry, I lost my train of thought. I was saying that, it changes the date. So this alignment happens every year, always. But the date, if you have a solar calendar, will change. because of this wobble of the Earth on its axis. Okay? So that means that it doesn't always happen on the solstice. And so some people claim that, oh, it's because it's happening on the solstice that it's special. But, you know, and then they also argued that they weren't talking about the center of the galaxy, they were talking about this dark rift in the galaxy. Well, the dark rift is fairly wide and fuzzy, and we can find the sun in that rift and the solstice over a 400-year period within this cycle of 26,000 years. So if they meant for it to be happening at the end of the Baktun, well, they had a 400-year window in which they could have done that. Is it significant? I don't know. Probably not. Those dark rifts, by the way, are nothing magical or mysterious or dangerous. They're actually places of life. These are dense clouds where there's a lot of dust, interstellar dust, where new stars are forming. And this is an image of that same part of the sky, but seen in infrared light. So this was visible light, and this is infrared light. And you can see that in infrared light, we actually see the dust itself. It's glowing because it's warmed by starlight. All right, the other thing that you often hear, and this is the question I get all the time. So I heard that there's going to be this planetary alignment in December 2012. And when people talk about planetary alignment, this picture, I think, is probably what's in their head. All of the planets lined up. And of course, you know, this is the way every textbook shows the solar system, right? With no idea of three-dimensionality, the fact that they're in a plane, the planets are all over the place in the disk, and this, in fact, never happens. Right? I think the mathematics work out that if you try to figure out how often this arrangement could happen, it's several million times longer than the age of the universe for it to happen once. So here's the actual arrangement of the planets on December 21st, 2012. They're scattered all about. Even if they were all lined up, it would make no difference. And I should say that even if the sun were exactly aligned with the center of the galaxy, any of these alignments, people often worry about, oh, it's going to have this extra gravitational tug and it's going to cause tidal waves, or it's going to cause earthquakes and volcanoes, or something like this. But the fact is, the tidal effects of the planets are minuscule compared to the tidal effects of the sun and the moon. Those are the two strongest things that raise tides on the planets. And the strength of those tidal effects changes by 25% every month because the moon is going around us. Right? So as the moon goes around us, the strength of that pull that it has on us, because it's in combination with the sun's pull, varies 25%. That's a big fraction. The amount of tidal forces that any of the planets exert on us are tens of thousands to hundreds of millions of times weaker than that. All right, so zero effect. It doesn't matter whether they're aligned or not. That makes no difference whatsoever. They have no discernible effect on planet Earth at all, no matter how they're aligned. But there are really cool alignments that happen in the solar system all the time. Pretty much every year, you'll get around 4 either solar or lunar eclipses, and 2012 is actually a normal year, so there are 4 of them. We've already had 2. In May 20th, there was an annular solar eclipse that you could have seen here. How many saw it? What was wrong with the rest of you? Good Lord. I went up to past Reno to check it out there, and here's actually a picture of it on my shirt. I'm wearing the same shirt. So this was after it reached the center point. One of the people there was projecting it with a telescope, and it was fun to get your picture taken with the eclipse on you. 1 month, or actually 2 weeks right after that, there was then a partial lunar eclipse because the sun and the moon were already lined up. The moon came around and ended up in Earth's shadow and was partially eclipsed. On November 13th, there'll be a total solar eclipse visible from the northern part of Australia. And then again, 2 weeks later, the moon's going to graze Earth's shadow, and there'll be a partial lunar eclipse. So we do have fun alignments. Here's another one. The transit of Venus. Venus went right between the sun and Earth, and we were able to see it in silhouette. So here's actually a picture of it from back in 2004. Then here's a picture of it happening here in 2012. So these alignments are actually pretty cool and kind of rare. How many got to see this one? All right, well, those of you who missed it, sorry. The next one is until 2117. So you'll just have to enjoy the pictures on the internet of all the people who got to see it. So we've already had some of our cool alignments for the year. All right, now I'm going to move on to some of the more realistic doomsday scenarios. And by realistic, I mean there's some kernel of reality in a lot of these scenarios that I'm going to talk about, which often then have students asking questions about them. And I should say the reason that I'm doing this is part of an educational program that I've been doing that's funded by NASA. The idea is to help educators actually work with students or public who are coming to them in various kinds of either classroom settings or after school or museums, and they have questions. And so we do workshops with them and help them do activities to help their audiences understand some of these different concepts. And so I specifically picked out some of the ones that are often kind of very frightening to people because there's some element of reality in them. So the first one I start with is global warming. How many of you saw the movie The Day After Tomorrow? So more of you saw that movie than saw the eclipse or the transit. That's wrong, because that was a terrible movie. The premise of that movie was that global warming happened all within a period of 2 weeks. It was insane. There was a sudden shift in the North Atlantic current, which shut off the warming that happens in the northern hemisphere. It led to these gigantic superstorms that brought high altitude air down to the surface and froze everything. I mean, the movie was pretty insane. I mean, they kind of were thinking, what could we do to New York? I know, let's hit it with a tidal wave and then freeze it. That's always, that's how these movie guys work. They sit around and what could we do to New York? Right? So there's this idea that, somehow there's going to be this catastrophic global warming that's going to occur in 2012. A giant chunk of ice is going to break off of, say the Ross ice shelf in Antarctica is going to break off, and we're going to have tidal waves, and it's the end of everything. And that scenario that we saw in that movie will play out. Well, I mean, if you're following the news, you actually have heard about a lot of ice melt. A whole bunch of Greenland melted this summer. The Arctic sea ice they're the least amount of summertime Arctic sea ice ever recorded this summer. So there's definitely things melting on planet Earth. But the reality of global warming is that it's something that happens over a long period of time, which is actually why it's such a difficult political and educational problem, because it's the kind of thing that people don't see instantaneous results. It's the kind of thing that you see over decades and generations of change. So we do see that global warming is happening. We see this melt that's happening all around the planet, but it isn't something that happens instantaneously. So 2012 is going to be one piece of the whole story of global warming, but 2012 is not going to be the end of us all. Related to that is this idea that extreme weather will increase exponentially. We'll have hurricanes galore, thunderstorms, hail, you name it, frogs. Actually, what was it? The Yangtze River turned red the other day. So I guess we're getting biblical plagues now too. But that's the common idea, right? That we're going to have this huge increase of storms. And of course, everybody notices it, right? Oh, we've had all of these hurricanes and this crazy weather. Everyone's always talking about this crazy weather. But I'm reminded of something that actually my weatherman in the Bay Area mentioned a couple months ago. He just said, people have short-term weather memories. They seem to forget that we had, last year we had the wettest year ever. And then this year we have a dry year. That things, they kind of forget what the weather was like last year, and they're only focusing on what happens right now. And they always have a tendency to think that it was the worst now that it's ever been. So Hurricane Isaac comes by and, oh my God, this is the worst thing ever. Well, what about all the other hurricanes? What about Katrina? right? Katrina was a terrible hurricane, and in fact, it was worse. So when we actually look at the data, examine the data, what do we find with weather? And this is a really difficult thing because there's a bunch of stuff wrapped up into this. But we notice, for example, with precipitation, rain and snow, globally, over the last century, we haven't been able to measure any change in precipitation. Now, it's important that I say measure, and I also say globally, because what we have seen is that certain places on Earth have had big changes. And that's actually why you hear the term global climate change more often than you hear the global warming. The Earth is getting warmer, but what it's causing is local climates to change. At least at first is the kind of thing we see, is that local climates will change, even though the average may stay the same for a while. Tornadoes also. We've been hearing about all these tornadoes, but if we actually look at the numbers of tornadoes, we don't see a trend in the numbers, at least not in the United States. And here's one that's really interesting, tropical cyclones. And here's where that word measure becomes important. If we look at least in the last couple decades, we don't see any change in the number of tropical cyclones, although there's a slight indication that there may be an increase in the intensity of tropical cyclones. By tropical cyclones, I mean all the things that become hurricanes, or they're called typhoons or cyclones, depending on which ocean they originate in. So we're not seeing necessarily a trend in the number, but there's a slight indication that there may be more stronger storms, which kind of makes sense when you think about the fact that if you're putting if you're raising the temperature of the air, you're putting more energy in it, which means there's more energy to have bigger storms. But there was a huge increase in the count of tropical cyclones in the 1960s. They almost tripled in the number. Why do you suppose that's so? That's right, satellite detection, said by an astronomer. It was satellite detection. Before the 1960s, we only were able to count the tropical cyclones that landed somewhere where people lived, right? So our count was just based on that, tropical cyclones that formed and hit somewhere that people lived. In the 1960s, we launched satellites that were able to observe the Earth from space, and we could see all of them that are happening all of the time. So the change in our technology, our ability to measure weather, has been increasing at the same time that there has probably been some change as a result of global warming. But the signal of the global warming change is lost in the change in our ability to detect. So we're able to detect more and more storms at the same time that there might be an increase in the total number of storms, but it's hard to actually find that increase in the signal because of our changing technology. But here's a fun sequence of graphs that I want to show to you. This is from NOAA, the National Oceanic and Atmospheric Association. It shows extreme weather events over the past decades in the continental United States. See if I can remember the colors here. Green are, I believe, hailstorms. Red are tornadoes, and blue, I believe, are what are called extreme rain events. So these aren't just regular old rain events, but very heavy rain events. What's the first thing you notice about this? Yeah. Why does the weather hate the East? That's right, someone mentioned it. It's the Rocky Mountains. The Continental Divide is right here, and they really do change the climate. There's a big difference in the weather over here because of the Rockies. And of course, this is why we all love to live out here. So nice. And I grew up in Michigan, where we had regular thunderstorms and tornadoes and things in the summertime. And when I came out here, the first summer I was here was August, and it rained. And people were like, "Oh my God, it's raining." And I was like, "What?" "Yeah, it rains." Like, you know, it rains every other day in the summertime, right? "No, it never rains." Must be that crazy global warming. So I'm going to flip through the years, and I want you to look for patterns. over the long haul, there's kind of an average that seems to be stuck to, at least for now. So we shouldn't expect 2012 to be any different than any of these years that we've just seen. All right, earthquakes. I'm going to speed up my rate a little bit here as we go because you're going to start to get the same story over and over again. Earthquakes are caused by the movement of tectonic plates. Earth is a solid rock, but it's actually not entirely solid. The interior parts are a little bit molten, and our crust is kind of, we call it a crust. It's rigid, and then it floats atop a bit of that kind of movable mantle. And then the interfaces between those plates are where we see earthquakes and volcanoes. Of course, you all know this very well because you live in earthquake country. I had to learn that because, I grew up in tornado country. But here's something that maybe even you aren't really aware of. There are millions of earthquakes across the globe every year, which means that they're happening all the time. Somewhere on the earth, there's an earthquake happening right now. They might be very small. But if we start to look at the numbers, we see that on average, there's about 1,400 quakes per year that are magnitude 5 or greater, and usually about 1 per year that's magnitude 8 or greater. And it's funny because, again, it's that same idea of people have short weather memories. They have short earthquake memories too. So the huge earthquake happens in Japan and causes a huge disaster, and everybody says, oh my God, we've never seen anything like this before. Except for the year before, and the year before that, and the year before that, and the year before that. There's been giant earthquakes, these 9.0 earthquakes. There's been at least one of them every year. And we've had one this year already, and we've had, I think, another that was just a bit smaller than that, located again near that same quake area. Actually, it was near the quake area that went off in 2004? That happened in Indonesia and led to that giant disastrous tsunami there. So 2012 doesn't seem to be any different than any of these other years. It's sticking with the averages. Now, one thing that I want to say is that even though 2012 doesn't seem like it's going to be any different than any other year, you know well that earthquakes happen, and it's wise to be prepared for them. But should you be afraid of a disastrous earthquake that's going to strike us on December 21st? I say no. I say be prepared for emergencies because that's always smart, right? In any kind of emergency. If you live in tornado country, boy, you better have a working storm cellar, right? Which we did. I was always freaked out when I came to places. You don't have a basement? Where are you going to go when the tornado comes? Volcanoes are pretty much the same story. They happen in the same areas where the tectonic boundaries are. On average, we see about 56 eruptions per year around the globe. There happens to be one going off right now in Guatemala, so of course that means, oh my God, the Mayans were right. It's happening in their own country. But it's an active volcano that's been erupting for a long time, so it's not that unusual that we should see it roaring to life right now. Some people often worry about the supervolcano idea. This is the idea that there are some volcanoes on Earth that are pretty disastrous when they go off. They have global impact. They're called caldera-forming volcanoes. They're these giant pockets of magma that sit just beneath the surface, and eventually when enough pressure builds up, the basically top of that surface crumbles down into it. You have this enormous release of ash into the atmosphere, and it's globally impactful. The last time, and we have one such volcano that's in the United States, and it's under Yellowstone National Park. And I believe the last time it went off, let's see, it's gone off twice in the last 2 million years. Now that doesn't mean it averages once every million years. That just means it happened twice in 2 million years. And people are watching it very carefully, and it doesn't seem to be that there's any change in the activity there. Right, so we're not due for, it doesn't look like there's any reason to worry about Yellowstone blowing anytime soon. There certainly is reason to keep paying those guys to watch it, I say. All right, meteor impacts. So the Earth probably hasn't seen something like this in 3 billion years. But Earth does get hit fairly regularly by objects from space. And in fact, just 3 days ago, Jupiter got hit by an object. It's on the internet. You can check it out. There are pictures. An amateur astronomer just happened to be actually taking video at the time when he saw the big flare-up happen. And that's kind of remarkable because Jupiter was hit just last year. And then, of course, the first time anyone had ever seen something hit another planet was back in, I think it was 96, when comet Shoemaker-Levy 9, which had been broken up into this long string, all impacted Jupiter, and we got this front row view of it. But I should say this, Jupiter gets hit a lot more often because, one, it's huge, and it's a bigger target, and it attracts things more. Also, it's close to a giant population of asteroids, so it's a lot easier for it to get hit. But Earth gets hit too, and we have plenty of examples of that in our geological history. Just back in 2008, there was this really remarkable event where we actually saw the rock in space first, and then predicted exactly where it was going to touch down, and then found it after it did. So it was observed to enter, people saw the fireball, then a scout team went to look for it and actually recovered, I think about, 10 kilograms of this thing. So that was cool, because that was the first thing ever first observed in space and then recovered on the ground. It was a rock that originally was about 3 to 5 meters in size, so car-sized. This is the kind of thing that hits us frequently. Probably almost on a monthly basis, one of these things lands on Earth, or enters at least in the atmosphere and burns up in it. Forms a fireball. Sometimes those get caught on camera and you'll see them on the evening news. But most of them get missed, and why do you suppose that is?
They only last a second.
Well, they only last a short period of time, that's true, but there's another good reason. The ocean. Most of Earth's surface is covered in water, and people don't live there, right? So in 75% of the time, no one's ever going to see these things because no one's around to see it. It's the old classic tree falling in the forest, except it's asteroid landing in the water. Along that same lines, there was an event that smashed into Russia back in 1908. This enormous explosion that flattened trees for, 50 kilometers. Trees were completely obliterated, and any living thing in that area was wiped out. Luckily, there was no people living there. And this is another one of those examples of most of the Earth is uninhabited. And so these things, even though we think they actually happen probably on the order of 100 to 200 years, every 100 to 200 years, the only time we've actually in recorded history seen one was back in 1908, just because the chances are against it actually landing anywhere where people live. Which is good, because this is, order of, nuclear bomb type destruction. So this is, this would destroy a city if it happened over a city. Then there was an event that happened about 50,000 years ago, made a 1,200 meter crater. It's in Arizona, and it's called Meteor Crater. That was a pretty impactful event. And then there was one that actually happened in Mexico near the Maya lands, near Chicxulub, Mexico, 65 million years ago, when it really didn't look anything like it does now. It was a global catastrophe that killed off the dinosaurs. You've probably all heard about that one. Seen the movie Armageddon, which began with a little introduction to this. Another horrible movie. But the threat is actually real. Asteroids do hit the Earth, and they still can hit the Earth. And that is why we have people who are making it their job to go searching for and trying to assess the risks of all the asteroids they can find. And you can go to this website and actually check out all of the known asteroids that pose any possible dangers to Earth, meaning that they actually can possibly get close enough to Earth that they could be deflected toward us in a future swing around the planet. And you'll be happy to know that there's nothing on that list that has an even 1 in 10,000 chance in the next several centuries of hitting us. So for now, we're good. But again, I'd like to keep paying these guys to keep watching, just in case. Because the only way we're going to survive one of these big ones is to know about it years ahead of time so we can do something about it. Those movie scenarios, you know, Earth is a goner. The other one that you hear about is that the magnetic pole of the Earth is going to shift in 2012. It's going to wipe out all of our data. Goodbye, internet. Goodbye, finances. It's the end of the financial world as we know it. The reality is that Earth's magnetic field does flip. And we know about that because we can read it written into the history of the sea floor. So the Mid-Atlantic ridge is this place where two tectonic plates are separating, magma is flowing up, and there's iron in that magma, and as it cools basically with the magnetic field of Earth at that time, frozen right into it. And so all we need to do is drag magnetometers across the seafloor, and we've done that along the whole ridge, and we come up with this record, this history of the magnetic polarity of the planet over time. And we see that it flips all the time, north and south, south and north. This is the magnetic poles. These are not the physical poles of the planet. The planet itself doesn't flip over. This is the magnetic field of the planet that actually changes during these times. And you can see that it's not particularly regular. There's there's periods where it seems to happen more frequently, and then periods where it didn't change for over 100 million years. So it's hard to predict when exactly a next one will occur, but one of the things that we can see in this record is that they do not happen quickly. They happen over periods of thousands of years when they occur. And they've obviously happened a lot, and life has been just fine all the while, right? Life has continued, and we see no correlation with this record and any extinction in the fossil records. So we know that there probably isn't any effect on life as a result of these things, other than maybe pigeons having to relearn where to fly. Yeah, question?
Why the dark period in Cretaceous? Any theories on that?
I don't know enough about it to know what possible explanations there could be for this long period where it stayed unchanged. Yeah.
Aren't we in the middle of a shift right now? Like, haven't they been examining if we are actually?
The question is, aren't we in the middle of a shift right now? And what we've been observing is that we've seen the magnetic poles move around, although we think that that's probably common, that they just do that. They don't stay put with time, that they tend to actually wander a bit as they go, although we think that that probably speeds up when a flip is about to happen. And there's been teeny tiny little bits of information that maybe the field has gotten weaker over the past few hundred years, but it's really kind of early in the study to know if that's the case. The models that try to figure out and try to model and predict this are very conflicting and difficult to interpret. And so it's really hard to actually match the data with any of those models at this point. So it's really hard to say whether or not a shift is happening or not. But even if it is, it would take thousands of years to complete. It's not all going to happen in one day. Oh, and the other thing, of course, is I wanted to make that point, the geographic poles don't shift. If the geographic poles were to shift, that would be a catastrophic event because it takes a ton of energy to move the planet physically around and shift the thing. It takes, one of those giant asteroids to smash into the planet to change the spin of the planet. Solar storms. How many of you heard about this one? Giant solar flare is going to happen. It's going to wipe us out. They say, of course, that we're reaching solar maximum and it's going to happen in December 2012, and that's it. This giant flare is going to come off the sun. It's going to hit Earth. It's going to wipe out our electrical system. Civilization comes to an end. Well, so we've been watching the sun now very carefully for over 400 years and have seen that the sun goes through this cycle of activity related to the sunspots. The sunspots actually happen to be like the footprints of these big magnetic loops that are in the sun's atmosphere. These loops erupt into what we call flares or coronal mass ejections. They're big bubbles of magnetism that explode out into interplanetary space, and they shoot hot gas throughout the solar system, which does sometimes smash into the Earth and causes Earth's magnetic field to wiggle all about, causes electrical disturbances on the planet. But this is the actual prediction for the current sunspot cycle. So this is pretty fresh. This was just updated this month. This is where we are right now in time, and this is the last solar cycle, and this is where we're headed. The actual maximum probably won't occur until the fall of 2013. So all these people who are telling you it's scientifically been proven the solar cycle is going to come to its peak. Now, what is the peak? It's basically there's more of the storms happening. And it tends to be that the biggest storms happen actually on this side of the cycle. They tend to happen as the sun is coming down from the peak that we have the biggest storms that we've ever seen. In fact, the biggest storms we have ever observed, of course we've only been observing them for a few decades, in X-rays, happened in 2003 on the other side of the maximum. So if this cycle continues with the prediction, we'll see the biggest storms actually occurring late in this decade. Also of note is interesting is that the cycle has been the weakest cycle in over 100 years. And they have been steadily weakening for the last few cycles. Solar scientists are trying to figure out if this is significant in any way. But it also just means that the chances of one of these big solar storms doing something catastrophic on Earth are pretty low, actually, in this cycle compared to past cycles. And the sun has been doing this for 4.5 billion years. So far, we've been just fine. All right, so we do have, our technology can get interrupted by these storms when they do hit us. But this disaster scenario where it blows away our atmosphere and leaves us open to space is impossible. Our magnetic field actually shields us from these storms. So the particles don't directly impact the Earth. They get deflected by the magnetic field. And then the magnetic field wiggles all about and actually induces currents on the planet itself. Planet X. All right, so there's been this idea that there's this mysterious planet out there. Some people think that the ancient Maya or the ancient Sumerians knew about it and they wrote about it. Although it's been shown that this Nibiru, it's called, was invented by a 20th century author. So no, the Sumerians didn't think it up. This guy thought it up and then blamed it on them so he could sell books. The other idea is that there's maybe a giant companion to the sun that's out near the Oort cloud, which is the leftover cloud from the solar system's formation, and that this planet disturbs the Oort cloud and sends a shower of comets into the inner solar system, one of which could wipe us out. And this is the disaster scenario. And I'll actually mention that this picture is a picture from a NASA artist who was writing this to describe an event we actually saw, or actually we saw the remnants of an event like this in another star system. We actually saw this type of planetary collision in another star system, or I should say we saw the remnants of it. And the artist was kind of depicting, the horror of that kind of event. This also is probably what formed the moon. So this is the kind of thing that happens in young solar systems. When they're first forming and they have a lot of planets that are all zipping around, things start smacking into each other. And this is where we think the moon came from. The large planetoid hit the proto-Earth, the spray formed into the moon, and then a new Earth kind of formed from the resulting of the two collisions. As the solar system ages, orbits tend to get normalized, all of the weird guys get thrown out, and by the time you're in a middle-aged solar system like our own, exciting things like this don't happen anymore. I should say, though, that if there was a planet on its way to smash into Earth in December of 2012, the conspiracy theorists would have you believe that NASA's keeping it hidden. They won't want to tell you because they don't want to, cause a general panic. But it would be visible in the daytime sky to everybody on Earth by now, right? It couldn't hide this thing, so it's not there. We also recently, it was mentioned in the introduction, I was part of an infrared mission that surveyed the whole sky in 2010. Even if it was a dark planet that wasn't reflecting any sunlight, it could not hide from WISE's infrared eyes, and we didn't see this thing because it would have been hugely bright in our survey. Okay, I actually just said all that. Okay, my last disaster. This is one of the fun ones, the gamma ray bursts. How many people have heard of a gamma ray burst? Ooh, a surprising number. Okay. So the idea is that very, 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 the most very, massive stars in our universe, when they explode, they do it in a big way. They explode and release as much energy as our sun puts out during its entire 10 billion year lifetime. And they put out that energy like that. Literally in a second, they put out all of that energy. It's enormous. And it can be seen all the way across the universe when it happens. And most of that energy comes out in the form of gamma rays, and they come out in gamma rays in these little jets that are basically along the magnetic poles of the star as it's collapsing. These jets of material get shot out, and all that energy is shot across the universe. And we can see it when it happens in galaxies all the way across the universe. And it turns out that we can see basically about one of these per day. Somewhere in the universe, one of these things is going off every day. That's pretty amazing. So it sounds kind of dangerous. Well, and it's true. It certainly would be if you're right in the line of this thing, and if you're within about, say, 30,000 light years of it, the flux of gamma rays would be lethal. So if Earth were just pointed, we're right down the end of this barrel, and less than 30,000 light years distance from it, basically what would happen is that the side of Earth facing it, because it happens like that, so the side of Earth facing it would get a dose of gamma radiation that would be lethal to all living things on that side of the planet. So basically half the planet gets killed. The ozone layer gets destroyed, which means now solar radiation can get through to the other half of the planet who survived. So the rest of the people who survived, they need to go underground and hide from the sun's UV radiation. So it is pretty disastrous. And there's been talk about whether or not anything has ever happened in our own galaxy and could explain any of the mass extinctions that have been seen in the fossil record. No one's been able to ever find a culprit supernova remnant, a remnant of these exploding stars, and actually say, oh yeah, that one went off at the same time as this mass extinction we see in the fossil record. But we can work out the numbers. Since we know how frequent these things occur, we can work out the numbers. There's 100 billion galaxies in the universe. One of these things goes off once a day. That works out basically then to a chance of 1 in 270 million of one going off in the Milky Way. Then, of course, it has to be on our side of the galaxy because it has to be within 30,000 light years. And the beam has to be pointed right at us, which is not particularly likely. So really, the chances are very, very small of any of this thing ever happening in any given year. So it's a kind of thing that's like, it's one of those cosmic dangers that's out there, but it's a very low probability event. Your chances of hitting the lottery are way higher. So if you're concerned about gamma ray bursts, you should go play the lottery instead, because seriously, if you're going to put any of your worry or energy or your money into anything, put it in the lottery instead of this. At least that goes to education. All right, here's my summary. The Maya did not predict the end of the world. However, there are natural disasters which are interesting and worth knowing about, worth studying, and worth being ready for. But we don't see any evidence of any of these things being globally catastrophic in the year 2012. And let me see if I had, there's my...